In this video, we'll take a look at some of the optimization challenges that virtualizing with VMware vSphere can potentially solve for you. So let's start out by taking a brief look at some of the challenges that can arise with a virtualized environment. And one of the problems that we might have is it may be difficult to locate performance-based bottlenecks. At times, it's hard to determine which resource is actually causing poor performance. For example, let's say that users are reporting an application is working slowly. Well, how do we know if it's a CPU or memory or network or storage issue? How do we identify and find those bottlenecks? And this can be really complex in both a physical server environment and in a virtualized environment as well. Another challenge with a virtualized environment is actually right-sizing our virtual machines. So how do we determine how much CPU and memory and disk space and network bandwidth is actually required by a virtual machine? And this can be a really challenging thing to determine. And if we don't properly size our virtual machines, we may end up wasting resources. And that leads to inefficient resource usage. So how do we make sure we're making the most out of not only our CPU and memory and the resources of our ESXi hosts, but also out of the storage capacity that we've purchased? We also need to make sure that we're properly placing our workloads, that the virtual machines are running on the ideal host, and that my virtual machine files are being placed on the optimal data store. And we need to make sure that our critical virtual machines are prioritized above less critical workloads. So how does VMware's vSphere product line solve these optimization challenges? Well, for the first two optimization challenges, identifying bottlenecks and right-sizing our virtual machines, we can use vRealize Operations Manager. And what vRealize Operations Manager does is it provides us a simple dashboard-based tool. So essentially, what vRealize Operations Manager does is it sits there and it gathers all of this information from vCenter and correlates it all and analyzes it all. And then it presents you a very simple dashboard that you can use to quickly identify which virtual machines have been improperly sized. Are there efficiency changes that we can make to make our environment run better? And that's the purpose of vRealize Operations Manager. How about efficient resource usage? Well, there's a number of tools available to us, right? Number one, we have thin provision disks. So if I create a virtual machine with an 80 gig disk, and it only has actually 20 gigs of data stored on that 80 gig disk, that virtual disk will only consume 20 gigs of actual disk space. That's a thin provisioned disk. Memory is also thin provisioned. So if I have a virtual machine that I've created with 16 gigs of memory, but it's only using 8 gigs of memory, it will only consume 8 gigs of physical memory on the ESXi host. How about placement of workloads? Well, what we have are a couple of load balancing solutions called Distributed Resource Scheduler and Storage Distributed Resource Scheduler, or DRS. And what DRS and Storage DRS will do is they will automatically migrate virtual machines from host to host or from data store to data store to load balance and equalize the workload. And so by placing these workloads on the optimal location automatically, we can ensure that we have balanced resource usage and that our virtual machines will work as well as they possibly can. We can also use storage policies to govern which data stores virtual machines are placed on. So for example, let's say I have a really critical virtual machine that needs to perform very well and cannot tolerate a lot of storage latency. Well, I could write a storage policy that governs this virtual machine needs to be stored on 15,000 RPM SAS drives or on high performance storage arrays. And then my storage policies, or as they used to be called, storage profiles, will take care of ensuring that that virtual machine is located on a data store that is compliant with that storage policy. And then we've got the prioritization of critical VMs. So there's a number of tools built into vSphere to accommodate this. The vSphere distributed switch supports quality of service marking of traffic. So what this means is I can identify certain criteria in my vSphere distributed switch based on a number of different factors. And basically, when traffic comes through and hits the distributed switch that matches our QoS policy, a tag is appended to that traffic. Right? So let's think about it this way. We've got all of these virtual machines running on an ESXi host, right? We've got many VMs running together on an ESXi host. So here is my ESXi host. And some of these VMs are going to be really important, and some of them are going to be not so important. Right? And let's say that this is a mission critical VM right here. Well, as traffic leaves this VM and heads for the physical network, it's going to hit a virtual switch, right? And in this case, let's assume that the type of virtual switch we're using is the vSphere distributed switch. Right, so here's my vSphere distributed switch. In that vSphere distributed switch, I can identify a quality of service policy that will take and append a value to that traffic, a quality of service value. So as that traffic leaves my ESXi host and starts to move out into the physical network, right, which we'll just represent by kind of a cloud looking shape here. As that traffic leaves my ESXi host and hits that physical network, that quality of service tag that's been appended to it is going to govern how important that traffic is, right? And the physical network hardware can actually recognize these QoS values and prioritize traffic appropriately. So with a vSphere distributed switch, we can specify quality of service on traffic that is actually respected by the physical network. We can also define shares and limits and reservations. So with shares, limits, and reservations, these are resource controls for virtual machines. Right? And we're not going to get really deep on these concepts here, but I'm just going to give you a brief explanation of each of these three resource controls. So shares are relative priority of a virtual machine. Right? So let's say, for example, one virtual machine has 1,000 memory shares and another virtual machine has 2,000 memory shares. Well, the virtual machine with 2,000 shares is entitled to twice as much memory as the virtual machine with 1,000 shares. And this is important because, remember, our virtual machines are running on an ESXi host, right? So again, here's this ESXi host. And the ESXi host has a finite amount of memory, right? So here's the actual physical memory of the ESXi host. And on this host, I'm going to have all of these VMs running, right? Here's all these different VMs that are competing for the physical memory of that ESXi host. And under most circumstances, maybe they can all get as much as they are configured for. Right? Under normal circumstances, maybe they're all getting everything that they ask for. But if the ESXi host starts to run low on memory and the demand of my VMs starts to exceed what the host can actually provide, that's when shares start being enforced. And the virtual machines with the most shares get priority access to those resources. So we have shares, we have limits, which basically just place a hard cap. Like, for example, you could set a memory or a CPU limit on a virtual machine. And we have reservations as well, which is a way to guarantee a virtual machine a specific amount of some physical resource. And then finally, we got storage I/O control and network I/O control, which again allows us to prioritize critical VMs. And basically what these two are shares, limits, and reservations. Right? except for storage and network. So storage I/O control allows you to define shares, limits, and reservations for storage bandwidth. Right? And what I mean by storage bandwidth is this. Here's my ESXi host, right, that my virtual machines run on. And the ESXi host has a physical connection to some sort of storage array out here that's somewhere else in the physical network. So as my virtual machines need to communicate with that storage array, I can assign shares, limits, and reservations, right, that control which virtual machine get priority access to that bandwidth. Right? And it's the exact same thing with network I/O control, right? But instead of communicating with storage, we're enforcing those controls on the physical network bandwidth that's available to my virtual machines. And the final solution to these prioritization virtual machines is VFlash. So here's what we can do with VFlash. With VFlash, we can go ahead and take an ESXi host, here's my host, and install some SSD capacity on the host, right? A solid state drive. And solid state drives are really fast, right? Really fast storage. And I could allocate a chunk of this solid state drive to a particular virtual disk on a virtual machine. And what this virtual disk will use the SSD for is a cache. It'll house some of the most frequently read data on that SSD drive. That way, when this virtual machine goes to access that data that it frequently needs to get to, it'll be served up really quick off of SSD. So those are some of the solutions that vSphere provides to common optimization.